We're going to talk about living in the matrix with bytecode manipulation. My name is Ashley Puls. I am a software engineer at New Relic. If you have not heard of New Relic, we are a software analytics company. Our core product is an application performance monitoring tool. It supports Java, PHP, Python, Ruby, Node.js, and .NET. And I work on our Java agent, which does the instrumentation of Java application and reports those metrics to our UI to provide actionable data to find and fix bugs. So today, we're going to talk about what is bytecode, why you should be interested in manipulating it. We're going to examine two frameworks in depth. We're going to look at a few applications, and then I'll talk about a few lessons I have learned along the way. So you all are probably familiar with this. We have our .java file. It looks something like this. We write it every day, right? And that .java file goes into our Java compiler, Javassist. Generally, we have it's an Ant, Maven, or Gradle. And if you run a command line with verbose, you can see it parsing your file. It'll do all the compilation, and it'll print out your .class file. And this .class file is essentially what contains the bytecode. And the bytecode is essentially the instruction set of the Java virtual machine. It's what gets read in, loaded by the class loader. And also another important thing to note is that the JVM includes a bytecode verifier. So if you do manipulate bytes, it will be verified at this step along the process. So why should you care about bytecode? Why should you care about manipulating it? Well, one, we're all here at Spring 1. It means most of us probably use Spring somewhere on our stack. And Spring uses bytecode manipulation frameworks, as does Hibernate, most of your languages that are compiled on the JVM, and your IDEs. I also think it's really fun, and hopefully by the end of this talk, you will too. And there's also multiple applications where you can use bytecode manipulation. And once you learn it, it's really the sky's the limit, and so it can be a really valuable tool. So what are some of those applications? Well, one area is program analysis. How many people have used Find Bugs? That uses ASM under the hood to analyze your bytecode and find bugs in your application. Some companies have code complexity rules. You only can have so many if-else statements in a method. Well, they analyze your code at the bytecode to determine what that code complexity is. Another segment of application is class generation. Your ORM frameworks, they're going to typically use proxies. There are security applications. If you want certain users to not have access to certain APIs, you can restrict it at the bytecode level. And your compilers for languages like Scala, Groovy, Grails, they're all going to use a bytecode manipulation framework. Additionally, you can transform classes without actually having the source code. So your profilers are going to do this. At New Relic, we use bytecode instrumentation to time metrics or methods. You can perform optimization, obfuscation. You can also add logging to an application. And that's actually the application that I'm going to focus on today to show you how some of these bytecode manipulation frameworks work. So take Sue here. She works at a bank, and she's in charge of their ATM. And her boss wants her to put together some audit logging. So she needs to log all the important actions, and she needs to log the important values for those actions. So I've written this extremely simplistic bank transactions class here that just does 100 transactions, logs in as Ashley with password, does some processing, and withdraws some money, and then prints out transactions completed. And I would identify the important actions here as logging in. We want to know every time someone logs in and every time they withdraw some money. So what we're going to do is we're going to put this important log annotation on those methods. And with this important log annotation, we're going to have the input parameter fields. And this is going to specify the input to our method, the indexes that we want to record. So we have our login and we have our withdrawal. And we're going to annotate them with important log. For login, we want to record the account ID and the username. So our fields is going to be set to 1 and 2. For withdraw, our fields is going to be 0 and 1 because we want the account ID and the money to remove. Then ideally, our audit log will contain something like this. A call was made to log in on bank transactions with our important parameters, our account ID and our username. And something similar for withdrawal. A call was made to withdraw on bank transactions with our designated important parameters. So part of how we're going to hook this up is we're going to use a Java agent. And a Java agent essentially allows you to modify the bytes in the JVM without having the source code. And it is a core feature in the core JDK. It was added in 1.5. And to understand how a Java agent works, let's first look at a Java typical process. We run Java with the class that has our main method. It goes into the JVM. It's loaded by a class loader. The main method is called, it does our processing, and transactions completed gets printed out. With the Java agent, we have this flag we need to add to our input. And it says Java agent, and we have to list the path to our agent jar. And your agent always has to be in jar form. This tells the JVM to go look in that jar, look at the manifest, and find what class represents the agent. Then call the pre-main of that agent. And this is before the main of our actual application. So this is essentially a hook to do some setup. While we're in the pre-main, we can register something called a transformer. This allows us to get the bytes of every class loaded, make any modifications we want, and return the modified bytes. So in our case, bank transactions is going to go to our transformer. We can make modifications, return those modified bytes, and those are the bytes that will get loaded by the class loader. Then the main will run, do its processing, and transactions completed will get printed out. So what does the code look like? Well, one, I mentioned you need something in your manifest. You have to have the pre-main class set to your agent, and that's the class with the pre-main method. So here I have my pre-main method, and I'm just printing out starting the agent, and I'm registering this important log class transformer. If we look at this class transformer, it needs to have the method transform. And note here that we get the class name. And we should see every class that's loaded into the JVM get called into this method. So we can do something like just print out the name of the class. If we do that, we can see starting the agent, and then we can see each class getting loaded with the bottom class being bank transactions there. We also get the byte array that represents the class. So really what we want to do is we want to manipulate the bytes here, and then instead of returning null, return the modified bytes. When you return null, that tells the JVM that you don't want to make any modifications to the bytes and to use the bytes as is. So how are we going to modify the bytes? Well, we're going to use a bytecode manipulation framework. And I've listed several up here. I'm going to focus on two today, Javassist and ASM. Let's start with Javassist. It stands for Java Programming Assistant. It's a sub-project of JBoss. And it actually has two APIs. It has an object-based and then a lower level, closer to the bytecode-based API. And I'm just going to show the object-based one today. And it is actively updated. So first, I'm going to try to give you a visual representation of the objects in Javassist. And then we'll go and we'll look at the code that we need to perform our audit logging. So in Javassist, there's essentially a CT class object that represents every class. So our byte transactions class is going to have a CT class object. And those objects are going to be stored in what's called a class pool. It's a container of CT class objects. And if you look at the implementation, it's a hash map, where the key is the name of the class and the value is the CT class object. So our bank transactions is going to have the key bank transactions with our CT class object as the value. Now, if we look at a normal Java class, we have fields, constructors, and methods. Well, we have the equivalent in a CT class. We have CT fields, CT constructors, CT methods. Really creative on the naming there. And so going back, we have our class pool, which has our CT class objects. We can grab a CT class object, and from there, grab any method on it. And on the method, we can now start making modifications. So we have a CT method with lines of code. We can insert code at the beginning using the insert before command. And here's the great thing about Javassist is we get to write pure Java. We just have to put it in quotes. So the annoying thing is that you have to escape your quotes within your Java, but you don't have to actually write bytecode. You don't even need to know anything about bytecode. You just get to write pure Java. Similar to insert before, there's an insert after to insert code at the end of the method. You can add a catch statement, and you can insert code in the middle of the method. So with this, we should be good. So now let's go look at the code. We start again with our agent, pre-main, and our class transformer. Now in our transform, for our audit logging application, we're going to want to take the bytes of the class and convert it to a CT class object. Then 2, we're going to want to iterate over all of the methods in our CT class object and search for ones that have the @important log annotation on them. If we find one with the @important log annotation, then we need to grab the input parameter indexes that we need to log and add our logging statement to the beginning of the method. So here, we take the bytes, we insert them into our class pool, and we retrieve them. One thing that you need to be careful with is when you're dealing with the transform and the class name, the package is going to have slashes in it. However, Javassist uses dots, so that can trip you up. Now we're going to iterate over all of the declared methods and check for the annotation. If the annotation's present, we're going to have to go through and get our parameter indexes. And then once we have those, we can insert some code at the beginning of the method to do our audit logging. So let's go and look at this getAnnotation method. One thing to note about Javassist is that there's essentially 2 buckets of annotations, invisible and visible. Invisible are the ones that are only visible at class loading time, compile time, and visible are loaded or viewed at runtime. So we only need ours at compile time, so it's going to be in the invisible tags list. We grab it out and return it. Now we can go look at how we're retrieving the parameter indexes. So we get the member value fields, and that's a string array, so we just iterate over and grab all the strings out of it. Then we just have to insert our log statement, and the main work is in create Java string. And here you see we're creating a string builder, adding our strings, adding our method name, adding our class name. One thing to note that if you're putting in multiple Java statements, you need to have your statements in between brackets. If you're just adding one Java statement, you don't have to have the bracket there. And then we can scroll down, and we need to now retrieve the values of the input parameters to our method. And we're going to do this using $1 and $2. So $0 represents this, the object that the method is on. And so we, on that first line highlighted, we have to add 1 because position 0 is actually going to be represented by $1 with Javassist. And then we just append it with the $, and that will pull the actual value of the method parameter. So now that's all the coding we had to do, and we have added audit logging using Javassist. What were the positives? Well, it's relatively simple. We got to write pure Java code. There wasn't too much programming to do. And there's relatively good documentation on Javassist out there. The negatives is that you're limited on functionality because you're not working at the bytecode level, you're working at the Java language level. And it tends to be slower than some of the other bytecode manipulation frameworks out there. So now let's look at ASM. ASM was started as a PhD project and was open sourced in 2002. It's actively updated. The 5.x version supports Java 8. And it also has 2 libraries. There's an event-based, which is similar to SAC's XML parsing, and an object-based, which is similar to DOM XML parsing. And today I'll just focus on the event-based library. So I'm going to start by looking at a class. And a class has many components, right? Has superclass, interfaces, attributes, fields, and methods. And with ASM, we can think of these as events. We're going to parse the class, and each time we come across a component in the class, we're going to think of that as an event. And these events are stored in the class visitor. So you can see the visit gives you access to the super class and any interfaces. We can visit attributes, visit fields, and visit methods. We're always going to see these in the same order, too. So for our audit logging, we know we're always going to get the annotations before we visit the methods. So we're going to have our bank transactions class. And that's going to get sent into a class reader. And the class reader is essentially the parser. And then we could just send those bytes to the class writer. And the writer is in charge of taking the parsed bytes and putting them back together in a byte array. So then we get out a bank transactions. And with just a class reader and a class writer, we should get the same bytes at the beginning and the end. Now, if you actually run this experiment, you'll see that the bytes are slightly different, but the functionality is the same. Now, what we want to do is add in a class visitor. And so this is essentially notifying us of the components that have been hit while parsing the class. That would be things like visit a field or visit a method. Now let's get to the code. Again, we start with our agent, our pre-main, and our class transformer with the transform method. We start out by just hooking up the class reader, which takes in the bytes, and passing the reader to the writer. Then that CR accept call is essentially saying perform the parsing, and then we get the byte array at the end from our class writer. Now we can chain in a class visitor, which I've named log method class visitor. And so here, now that middle component, that's log method class visitor. And what we want for the audit logging application is we only care about the methods. We want to check each method, see if it has the annotation, add the logging if it's needed. So in the class visitor, we only need to override visit method. And that's what I have here. I have this log method class visitor overriding visit method. One thing you see here is that visit method returns a method visitor. Just like there's several components of a class, there's several components of a method, right? We have attributes, annotations, compiled code. And so ASM has a method visitor. And you can see you can actually visit every opcode of the method if you want. And again, they come in a specific order. So we're always going to know if there's any attributes or annotations on the method before we have to actually visit the code. And you can chain multiple method visitors together, just like you can chain multiple class visitors together. So in our visit method, we're going to hook up the print message method visitor. And in that, we want to override visit annotation so we can see if our annotation's present. And then we can add the code in visit code, the logging code. So here I have the two methods overridden. And in visit annotation, we'll check the method to see if the important log annotation is present. And if it is, we need to check that field's property and get any indexes we need. Then in visit code, we should already know by then if the annotation was present. And if it's present, we need to add the logging. Here's the visit annotation code. And I'm not going to go over it line for line, but you can see that it hooks up an annotation visitor. So just like we have class visitors and method visitors, we have annotation visitors. And we need to chain that in so that we can look at the field's property on the important log annotation. So now let's look at the visit code method. So we check, is the annotation present? If it is, then let's add our bytecode. And now this can be what people are kind of scared of with ASM, is that you actually do have to go and write bytecode. So you have to know some things like what's on my stack, what are my local variables. But if you just want to hack around, you can actually get the bytecode pretty easily. And one way to do that is using Javap. If you want to do this, you can essentially write the Java code that you want to convert into bytecode. Then run javap-c on your class there. And it'll print out the bytecode. So this will give you something to start with when you need to go in and add your bytecode using ASM. And here you can see everything in blue is the actual bytecode. On each line, you get a 1 byte opcode. And there's a finite number of those. And then you can have 0 or more input parameters. And if this stuff interests you, I encourage you to look at the JVM spec. It has every opcode defined. Some of the things I think are interesting is like your load and your store are moving things from your stack and your local variable to and from. And they're parameter specific. So you have an I load. That means you're moving an integer from the stack into a local variable field. And you have an L load. That means you're dealing with a long. There's also things like invoke virtual, invoke special, and invoke static. Those are all ways to invoke various methods, be it instance method, constructor, static method. And there's ways of creating things like new classes using new, duplicate the top operand on the stack. So if this stuff interests you, I encourage you to go look at the JVM spec. It has all the opcodes in it. And one thing that I find convenient is that you can hook up Eclipse or whatever IDE you're using to print out bytecode using the external tools configurations. You set it up with Javap. Your working directory I just set to project location, which would be what project you've highlighted. And then your argument, your class path needs to be set to bin, and your -c with Java type name, so that's whatever class you currently have loaded in Eclipse. And so you can run that, and you can get the bytecode for whatever class you have in front of you in Eclipse. So kind of convenient. So now, hopefully, when you look at this code, it isn't quite as daunting. Essentially, we start with the visit field instruction and the get static. Now, you see the Java lang system. So that's the class. Out would be the field we're trying to get. And the L, Java, IO, print stream, that's the description. Then we're creating a new string builder. We're invoking it with that input string. A call was made to method. And then next on this screen, you can see we're adding the actual method name to the string builder. So that's all you need for ASM. The general positives for it are it has a small footprint, memory footprint, and it's typically pretty quick. There's very good documentation out there. I haven't seen new documentation for the 5.x version, but there's a lot of documentation on the 4.x, which supports Java 1.7. You have all the opcodes at your fingertips, so you can do a lot with it. And I would call ASM the industry standard. There's a lot of people using it out there, and so if you run into trouble, you can typically get help. The negatives are really the fact that you're writing bytecode, and so you do have to understand what's going on under the hood. And as a result, there tends to be a high developer ramp-up time. So now, let's move into some applications. How many people here use Hibernate? How many people here have seen this exception? Yeah, it looks something like this. It can be pretty frustrating. Did you know there's only 9 instances of throw new lazy initialization exception in the Hibernate source code? For some reason, maybe I've hit it too many times, but I thought there'd be a few more. So what actually happens when you see this exception? Well, let's say we have 2 database tables. We have one with a runner that has a name, a location, and a team. And the team's a foreign key to the team table that has a name, location, and description. So Hibernate's entity base, so we might pull a runner entity. We can pull me out. And you're going to get the name and the location. And if you're lazy loading, you're not actually going to get the team object. You're going to get a Hibernate proxy. And what this essentially is it's giving you the foreign key, but it's not loading any other information from that team table. And the reason to do this is that if you have a runner, and then you load the team that the runner belongs to, and then the team has a list of all the runners that belong to the team, and then you end up loading all those runners, and suddenly you've blown up your memory because you're loading half your database. And if you actually look at this and run it with the debugger, here you can see I have my runner. This is Eleanor Ashwood from San Jose, California. And you can see my team, and all of the fields on my team are null. And then Hibernate has added this handler, this Javassist lazy initializer. And if we open that up, we can see the handler has the Hibernate proxy interface. And right above that line that's highlighted, you can see initialized is false. So that means it hasn't loaded the data from the database. And you can also see that target towards the bottom is null. And that's where the data would be if it had been loaded. And so how do we load the data? Well, we call something like runner, get team, get location. And then it loads that team information, and we have access to it. Sometimes you get null pointers when you try to do things like access the fields off the proxy, because those actually still are null. It's only the target where the data lives. And so if you look at this in your debugger, you can see that initialize gets set to true, and then the target object contains all the data from the team database. But things like our city description and handler right on the main team object are still null. So you get this lazy initialization exception when you don't initialize these fields, like you don't pull in the team into memory, and you end your Hibernate session, and then you try to access the data. And the data hasn't been initialized, and so it throws a lazy initialization exception. Now, under the hood, what's happening? Well, Hibernate has a Javassist lazy initializer, and it has a get proxy. And the code that's up here is essentially all Javassist. Javassist has a proxy factory. Hibernate sets the superclass to be the class that we are essentially proxying. So in our case, it would be team. It adds the Hibernate proxy, or adds the interfaces, and then it sets a handler. And the handler is what gets called when you call a method on the proxy. So it calls this invoke, and then you can, if you want to reach the data behind it, you get the access to that, and you can call proceed.invoke. So it's pretty easy to use Javassist to set up a proxy, and this is one of the common applications that you'll see out there for Javassist. So why do we need a proxy? Well, there's essentially two things Hibernate's trying to keep track of. Is your data dirty? And have you loaded all the data in? And there's actually other ways that Hibernate can instrument your entities to perform all this analysis. And one way is through build time task. There's an enhancement task. Now, how many people, has anyone used the enhancement task? No. So you can also set up a Java agent to do the same thing at runtime, but I think most people prefer the enhancement task over the runtime one, because then you have this runtime fee of instrumenting everything, versus this does it at build, compiled, build time, so you don't have to worry about it when you start up your application. And Hibernate does have Ant, Maven, and Gradle plugins to run this task. Here's the Ant one. I'm also listed the Gradle one. And I'm not going to go into a lot of depth on how this works, but I just want to show you some of the places where Javassist is used for it. So we have the enhancement task, and it has a class pool. That's where we keep our CT class objects. It has the execute, that's what gets executed. And then it goes through all your classes, looks for the entities, and processes them. So for each one, it'll make a CT class object, and then go process that entity. There's an enhancer, and the enhancer is actually the object that has all the Javassist manipulation in it. So if you're curious to go see more than I'm showing, you can go pull up the enhancer in the source code. And it does a lot of work. And one thing I will note here is that Hibernate uses interfaces to tell when it's enhanced an entity. So number 2 there you can see is that it won't instrument it if it's already been enhanced. Well, it checks that by looking at the interfaces on the entity. Then it does a whole bunch of work. And the work includes things like adding fields to that entity. And here you can see, to create a new field, you just create a CT field object and add it to your CT class object. Then you can do things like set modifiers and add annotations. If you also want to add getters and setters for that CT field, that's pretty easy to do. There's a CT new method, and you can .getter and .setter, and that will create your getters and setters for you on your CT class object. So in this enhancer class, there's a lot of manipulation. Hibernate adds a lot of fields, it adds a lot of methods, and once you're done, it then converts it back to a byte array. And in this case, it'll then write out that enhanced class. So it deletes the old one, writes the new one, and then it's done. So I encourage you to go look at that class and see. It uses the insert before, the insert after, it adds fields, it adds methods. It's a great place to look for examples of Javassist. Now let's talk about Spring. Does anyone know what frameworks, bytecode manipulation framework Spring uses? And yeah, ASM. And that's the one I'm actually going to show you today. All of you have probably used Spring Music or have heard of it. If you haven't, for some reason, there's the GitHub. So Spring Music is an example of a lot of Spring components. And the one that I'm going to look at today is the configuration, right? We're all used to writing these, or we used to write big, long XML files that had all of our beans in them. And now we can do that in our code with the @configuration annotation. And when you use an @configuration annotation, you can use the @component scan. It takes in either a set of classes or a set of packages to scan for other components. How many people have used component scan? Is that pretty common? Okay. So an album controller, which that's all we're looking at here. We have the controller annotation. So it'll pick that up and register album controller as a controller with the application context. And there's 4 components that scan looks for. The at component, which is the album repository populator for Spring Music. That repository, that'd be your Mongo album repository, your JPA album repository in Spring Music. That controller, we already saw the album controller. There's the error controller and info controller too. And then it looks for the at service annotation. So what's happening in the code? Well, there's a class path scanning candidate component provider. And this has a find candidate components method. And what I want to look at specifically here is essentially it goes through the resources and grabs the metadata for each resource, where a resource is essentially a class. So what's going to happen is we're going to have our resource, we're going to pass it into the simple metadata reader, and then we're going to get out metadata. And here you can see ASM being used. So it's setting up a class reader and passing in the resource as a stream. And then it has a visitor hooked up. It's parsing the class and then storing all the metadata information. So we have our class reader, we have our visitor. Now, note earlier in the example I showed, there was also a class writer. Well, we only need a writer if we actually want to modify the bytes. In this case, we just want to analyze the code and see what's present. So we don't need a writer. So here's the annotation metadata reading visitor. It overrides visit method, chaining in a method visitor. So we can add that. And then it overrides visit annotation, chaining in an annotation visitor. And if you continue drilling in, you'll see that the method visitor looks at annotations on the method, and the annotation visitor looks at annotations on the classes, and pulls out any of the properties on the annotations. So one thing you probably have also seen is that Spring Core packages in ASM now. And I think this is an interesting story. There's the JIRA on it. But essentially, people wanted to run Java 8 with Spring 3.x. And 3.x was hooked up to ASM 4, which only supports Java 1.7. And what the Spring people found out is that essentially ASM checks each class for its compiled version. So if you're compiled with 1.8, then you're going to have a version number of 52. And it'll throw an error saying, I don't support this. So essentially, what Spring did was go in and take out these checks. And they found that the code worked fine for parsing the class and getting the metadata for 1.8 using ASM 4. So that's why they now include it in Spring Core. Now let's talk about a few lessons that I've learned. And one is when you're dealing with bytecode manipulation, it's important to take small steps. Don't write a huge, long file of opcode, bytecode, and then expect it to immediately work and be verified and correct. You really need to write one line at a time, think about what's in your stack, think about your local variables, and then write another line. If it's not passing the verifier, change one thing at a time. Otherwise, you'll never get it to work. And also know that not only does the JVM have a verifier, but ASM also has a separate bytecode verifier. And so it's good to run them against both and verify that your bytecode passes both of them. 2, it's important to think about class loading when you're modifying classes. So essentially, if you're using a Java agent, you're going to hook up a transformer. That transformer is going to see every single class that's loaded into the JVM. It doesn't matter what class loader is loading the class. So if you're adding fields with your special object you may be created, you need to make sure that the class loader can also see that object. Otherwise, you're going to run into trouble. And if you're using Javassist and you're using something like an application server that has multiple class loaders, you have to be concerned about your class pool being able to see your class objects. So you might have to register a new class path to your class pool to get it to see your class objects. And you can also do, just like you chain class loaders, you can chain class pools together. So if it doesn't find the CT class object in its class pool, it can go look at its parent. And then finally, you have to be careful when transforming classes. There's also the ability in the JDK to retransform classes. So a class may have been loaded and you might be using it and you might decide, now I would really like to add some instrumentation to this class. Well, one thing you have to be careful of when you retransform a class is that you can't change the class structure. So you can't go adding extra fields or adding methods. And so you have to think about, are you retransforming this class or are you transforming it on startup? Because if you transform a class when it's loaded for the first time, you can add as many fields or methods as you want. So there's a lot of applications out there that you can use bytecode manipulation frameworks for. You can help find bugs, the logging application I showed today. You can obfuscate source code. You can perform pre-processing like we saw with Hibernate. You can write your own compiler if you're really optimistic. You can restrict your API calls. You can do things like perform code analysis and see if multiple threads are accessing a collection. You can lazy load data from the database. You can find differences between jars by inspecting them. And so I encourage you to make bytecode manipulation frameworks your friend. Someday they might save your job. And just if you do like this type of stuff, we are hiring at New Relic. And any questions? Silence.
How does it call the pre-main before the main? Because when you build the JVM, it always calls the main method, right?
Yes. So it's part of the JVM and the JDK spec that if you hook up an agent, then the pre-main will be called before the main method. That's just standard.
The name of the method has to be the pre-main.
Say that one more time.
The name of that method has to be pre-main.
Yes. Just like when you have a main method, you have to have a certain signature. Same thing with pre-main. Yeah.
The Javassist CT classes and so on, are they assignable from the standard reflection classes, methods, etc.? Transformable or generatable from?
Yeah, so the question was, are the CT class objects, essentially, do you have access to them through reflection? So you could reflect on a class pool and get the CT class object, but you wouldn't be able to just take the general class and reflect to get the CT class object. You'd have to kind of reflect into the Javassist code. Yeah. Yes?
Javassist, you insert Java source code. So what happened if Java source code is invalid? It crash JVM? Invalid code. Because you inserted, well, ID is just a string. ID wouldn't interpret it.
Yeah, so the question was, if you have invalid Java code that you insert in using Javassist, what happens, right? Well, that's going to get transformed down to bytecode. And actually, if you look at Javassist, it uses ASM under the hood to do its bytecode manipulation. And so it's going to go through the bytecode verifier, and it's going to fail there.
But before that, you need a compiler. You're trying to understand what is.
So at compile time, it's a string, right? So you're not going to, it's not going to fail then. Runtime, yes, yeah.
Except the string, you basically need a compiler to
Yes, it's
components, and then you call the ASM.
yeah, so it's going to get compiled down to byte. Javassist is going to convert it to bytecode, and the bytecode's going to fail at runtime. Yeah.
Yeah, it could have failed in the compiler time.
Correct. Yeah.
Can you also more of sharing the
Yeah, so the question was, can I talk some more about sharing between class loaders? What in particular about class loaders would you like to talk about?
Like in my experience, this transformer class and then basically the other class will let you go. I don't see you what do you do?
Yeah, so a lot of, all the pretty much app servers have specialized class loaders, right? And most of those class loaders do things like check themselves before they check their parent. And so then you can run into problems if you have a class that, like a field that's a special object that's on a higher up class loader, and that class, if the class loader below only checks itself for that object, then it's going to fail because it's not going to see it loaded on another class loader. So you just have to be careful. You either can hook it up to be on your Bootstrap class loader and then everyone can see it, or you have to make sure that that class loader is also loading that specific object that you're adding.
Are you saying that you are kind of reparenting these transform classes in some other place in the class hierarchy?
You would essentially have to, yeah, kind of parent that class to be in the, so it can be loaded by the class loader that's loading the class that you're transforming, if that makes sense. Or someone in its parent chain that it can see. So it's just something you have to be really careful with. Especially when you're using a transformer, you can tend to think that, well, my transformer is seeing everything, so it shouldn't matter who's loading the class. But it actually really does matter because they're two separate paths. Yeah. Yeah, so CGLib Hibernate actually dropped their support for CGLib semi-recently. Spring still uses it. The classic case that you see CGLib used for is similar to Hibernate's proxy case, where you generate proxies and hook it up. And it's probably, there's kind of a realm where you have ASM, your very low level, and then you have like AOP frameworks that would be very high level, where you're really writing Java code and just adding some stuff before the method's called and after the method's called. And CGLib lines in the middle, similar to where Javassist is. Yes? Difficultly. Yeah, so it's hard. The question was, how do you test transformers? It's hard to actually test a transformer in a very basic unit test. You almost have to move up a level where you can write a test that you can hook in your agent with your transformer and then verify what's happening at that level.
You might be able to load the transform class, basically execute it at some level and then see.
Yeah, exactly right. So if you go up a level and hook in your agent with your transformer. Oh. Yes, so you would have to use create a special class loader that's going to go through your transform, and you could do that, yeah. Yes. So you don't have to use an agent to transform your bytecode. So we saw with Hibernate, they were doing it at build time, which wasn't using an agent. The thing that's nice about the agent is that you get access to all of the classes. If you, for example, wanted to create proxies, you then have to worry about everyone calling your proxy as opposed to the class behind, and someone might still have a reference to your original class. So I find it as a very easy way to instrument bytecode. And one of the nice things about it So I have my bank transactions here, and I just have it essentially printing out methods. So if I don't run it with an agent, I just see the logging, processing, remove, logging, processing, remove. And then I can go and run it with Javassist. And now I see all my logging. So the withdraw, the logging, and I can do the same thing with ASM. And then if I go and look at these actual run configurations, so they're all running the same class. And the only difference is the actual VM argument. It's the Java agent. So for my ASM application, I'm hooking in the ASM jar I have. And for Javassist, the Javassist. And then I just take that out, and now I don't have my bytecode instrumentation. So if you're doing something like audit logging and you realize it's too performance intensive and you need to run for a little while without all this logging, you just remove your Java agent, and everything works as it should without your logging then. So that's also one of the nice features of using a Java agent, is that it's easy to say I want to instrument and then I don't want to instrument just by taking in and out the Java agent.
But I mean, in Spring applications, even though when I use the component scans, I don't specify, at least in some cases, I don't specify an agent in JVM. So how does Spring do it without the agent when still doing the instrumentation?
Yeah, so the question was, how does Spring use ASM without having to use a Java agent? So what you're doing when you have your component scan is you're telling it what packages to scan. And then it's going and grabbing those resources. And then it's loading those resources in and hooking up a class reader and a class visitor and just parsing for data. So it's not actually changing the class that's loaded in the JVM. It's not changing the bytecode at all. It's just being given the resources, the class, and then parsing it and using ASM as an analysis tool. So it doesn't need to be hooked up as an agent and change bytes or anything like that. It's just using it to examine what's in your class.
Why do we need to use ASM? Why can't we just use the JVK's class metadata?
So you could do like reflection or something like that, but reflection's really slow. ASM's going to be a lot faster than reflection. Yeah.
So more and more elaborate tools using the bytecode manipulation, and if you use an agent, you could in the case that you need multiple different agents, was that causing any kind of a conflict?
So per the JDK spec, you can hook up as many agents as you want. You have to be careful that if like some of them are relying on certain bytes, that they could be stepping on each other's foot. But generally what happens is, the first one gets loaded, it can register whatever transformers it wants. The second one, its pre-main method gets called, it can register other transformers. A third one can get called and it'll register its transformers. And then when the class is loaded, it'll hit, the bytes will go through each transformer. So you'll get your input bytes, they'll go through transformer 1, output bytes will go into transformer 2, those output bytes will go into transformer 3, etc., until you've gone through all the transformers, and those bytes are what will get loaded into the JVM.
So in the class step, can you find out what transformer have touched?
There's no metadata on the class to determine if a transformer has touched it. Anything else? Okay, thank you.